In this video, I'll talk about solution concentration parameters. We often need to know how strong a solution is. One of the ways we never do it is just by looking at it. And yet, it seems like all pictures of scientists have them staring at a flask with colored liquid in it. But at any rate, there are several ways that we can talk about the concentration of a solute in a solvent. One of those ways is with percentage, either a mass percent, in other words, the mass of solute in the mass of solution, volume, or mass volume. These are all used, many consumer products, medicine, all around the home. Very common to see concentrations of solutions in these percentage type factors. But in chemistry, we often use molarity, and that's because we deal with moles and it's much more convenient for us. There's also a type of concentration that's called molality, and we'll talk a little bit about that. Okay, so let's examine the percentage concentrations. First is mass. The mass percent is the mass of the solute divided by the mass of the solution. Notice it's the mass of the solution, not the solvent. Okay, so let's look at a problem. What is the concentration of a solution made with 5 grams of sodium bromide and 75 grams of water? Well, we're just going to take the mass of the solute divided by the mass of the solution. Remember, the mass of the solution is going to be the total mass. So it's going to be 5 plus 75. So if you do that and multiply it by 100 to make it into a percentage, you get it's a 6.3 mass percent solution. Another type of percentage is volume. And in this case, you have the volume of the solute divided by the volume of the solution. Once again, it's the total amount of solution. So watch out for problems where they give you an amount of solvent and an amount of solute. Make sure you add them together to get solution. Okay, so if a solution is made by combining 6 milliliters of acetic acid with enough water to make 125 milliliters of solution, what is the concentration of acetic acid? Well, we're just going to take the volume of acetic acid divided by the volume of solution. And here they gave us the entire volume of solution. So multiplying it by 100 to get a percent, we get 4.80 volume. The third type of percentage problem is really not a percentage problem, but it's used so often in medicine that we really have to show it to you. It's the mass volume percentage. Now, in any other type of percentage in the world, you just use the same units on the top and the bottom, and percentages are usually unitless. However, the mass volume is expressed as a percentage, but it really is grams per 100 milliliters. So it's grams of solute divided by milliliters of solution times 100. So if a technician makes up an IV solution by adding 18.0 grams sodium chloride to enough water to make 2.00 liters of solution, then what is the percent NaCl, mass volume? Okay, so we're going to need to change the 2 liters into milliliters. Then we're just going to take 18 grams divided by this number in milliliters. Okay, so, and that is going to be 2,000 milliliters. Remember, it does have 3 sig figs, although I didn't write it this way here, times 100 to give us our percentage, and that is 0.900% mass volume. By the way, this is the concentration of normal saline, which is a common IV fluid. Next, we have molarity. This has a special symbol in chemistry. It's a capital M, so get used to this. If you're seeing something that it says something M, that means something moles per liter. The units are moles per liter, and so in order to calculate it, you need to know the number of moles and you need to know the number of liters. What is the molarity of a solution if 3.70 grams of sodium hydroxide is combined with enough water to make 100 milliliters of solution? Well, they didn't give us moles, they gave us grams. So we're going to have to go from grams to moles, and then we can use our volume to figure out the molarity. Now our volume here is given in milliliters, so we need to change that to liters. Did that all in one step here. I take the mass of sodium hydroxide times a factor from the molar mass to find the number of moles of sodium hydroxide. Then I divide by the volume, and dividing is the same as multiplying times 1 over, and then multiplying it by a factor to change the milliliters to liters. And this comes out to be 0.925 molar. So when we talk about a concentration of a solution in chemistry, we'll often say it's a 1 molar solution, or a 2 molar solution, or a 0.925 molar solution. Molarity is used all the time in chemistry. All right, let's get to molality. Later on, we're going to be learning about colligative properties. And colligative properties, in order to calculate the colligative properties of a solution, you need to know the molality. Now, the molality is the number of moles of solute divided by the kilograms of solvent. Now, for water, a kilogram weighs, a kilogram of water has got a volume of 1 liter at, well, 4 degrees and up, at room temperature, basically. I want you to notice that kilograms and moles, neither one of them are temperature dependent. However, volume is. So when we calculate molarity, it is dependent a bit, at least, on the temperature. The density of water varies depending on its temperature. So its volume changes. Its mass isn't going to change, but its volume will change. So molality is not temperature dependent. But at low concentrations and at room temperature, the molarity is almost equal to, if not equal to, the molality. All right. We're not going to do a whole lot with molality, so I'm introducing it here so you understand what it is, but we're not going to do problems with it. All right, just like any other rate or concentrations, we can use these concentrations to make conversion factors. And I'll talk more about that in the next slide, or I'm sorry, the next video. But for right now, let's just look at these. Using a concentration in mass, percent mass, you can convert between the mass of a solution and the mass of the solute in it. The volume percentage can be used to convert between the volume of solution and the volume of solute. The percent mass volume can convert between milliliters of solution and grams of solute. And finally, molarity can convert between liters of solution and moles of solute.